Chapter 1. Get to know your soil. In this chapter, we'll learn what is soil, how soil was formed, reading the layers, sand, silt, or clay, testing soil's texture, the structure of soil, examining soil structure, promoting drainage, encouraging soil life, and the industrious earthworm. Gardeners are an idealistic bunch, so it's only natural that they try for ideal soil. The soil-experienced gardeners crave is deep and easy to work. It allows plants to push through easily and develop many long roots. A handful of ideal soil has a nice crumbly feel and a chocolate color. It smells earthy and rich, even sweet. Such soil is called loam. Sidebar. Did you know? Tilth. In addition to loam, there's another word that describes the structure of soil. Tilth. It comes from an ancient word for cultivation, as in to till the soil. Soil in good tilth has all the wonderful characteristics of loam. Good tilth means good soil, so it's something to strive for. Loam, sweet loam. Technically, loam refers to specific, well-balanced soil texture, but it's commonly used more loosely to mean ideal soil. That's not surprising, as both meanings of the word are similar in terms of physical characteristics. These physical qualities work together to promote healthy plant growth. When one is out of line, the other characteristics may suffer. Plant growth suffers too. Of course, ideal soil is also fertile soil. When people use loam in its looser sense, they imply good fertility as well. The balanced texture of loam means it retains a good amount of water and nutrients. It doesn't dry out too fast after it rains, yet it doesn't stay soggy either. Loam's well-developed structure resists compaction and reduces the risk of erosion. Such soil keeps its small crumbs when you dig it and when thunderstorms pound it. Good structure, in turn, ensures good drainage, so long-lasting puddles never form. Loam contains lots of organic matter, which in turn enhances all the other physical characteristics. Organic matter also ensures healthy soil community with large populations of earthworms and other beneficial organisms. Soil building consists of making your soil as much like loam as possible, or, if you're blessed with good loam, maintaining its productive qualities. That means fixing those characteristics that are less than ideal, but easy to change, such as drainage. Soil building also means learning how to manage or compensate for the characteristics you can't change, such as texture. What is soil? Though the earth beneath our feet seems solid, only half the soil is hard particles. The other half is a combination of space, air, and water. In good soils, about half this empty half is filled with water. Dissolved in this water are lots of chemicals, including nutrients essential for plant growth. The remaining space, or air, is also important. It supplies oxygen to plant roots and soil organisms. Though you may not realize it, good soils are teeming with a variety of life. Most soil creatures are microscopic, though some, such as worms and ants, are easy to see. Plants, and gardeners, depend on soil organisms to convert nutrients into forms they can use, and to recycle nutrients from organic matter. The different forms of life present in soil interact to create a complex ecosystem. One of the primary ways to build super soil is to nurture this ecosystem and keep it from getting out of balance. Did you know what's in your soil? Mineral particles of varied sizes, pebbles and rocks, air, water, nutrients dissolved in water, bits of undecomposed leaves and other organic matter, well-decomposed, unrecognizable organic matter, humus, and many organisms of varied sizes. Our illustration shows the 50% of soil particles and organic matter, 25% as air pockets and pores in the pores of the soil, and 25% as water in the pores of the soil. The minute pockets and channels between the solids in the soil are called pores. This ideal loose soil has lots of these and is therefore described as porous. Air could easily enter to reach plant roots, and excess water easily drains away. The solid portion is mostly tiny bits of pulverized rock. The size of these particles determines the texture and therefore much of the physical character of the soil. Solid portion also contains bits of dead material in varying stages of decomposition, known as organic matter, which eventually decays into a fine material known as humus. How your soil was formed. The nature of soil in a particular spot is determined by interactions among several factors. Parent material, climate, topography, living creatures, and time influence each other to create soil, as illustrated below. Parent material, or rocks, from which the soil formed, is largely responsible for texture and sometimes for alkalinity. Sandstones weather into coarse, sandy soils. Soft shales evolve into heavy clay soils. Granite bedrock usually resorts in more acidic, sandy loam. Soils derived from limestone are usually fine-textured, fertile, and neutral to alkaline. Climate determines the nature and degree of weathering. Lots of rain or snow greatly speeds up soil formation, but it can also wash away nutrients. Soils in dry climates are often very fertile when first irrigated, but where evaporation rates are high, salts in the soil and irrigation water can concentrate near the surface and reach levels toxic to plants. Such soils are either saline or sodic, which you can see later in the book. Temperature also affects weathering. Alternate freezing and thawing speeds up the crumbling of rocks. In warm climates, biological activity takes on a much more important role. Warm temperatures also speed up chemical breakdown of iron from parent rocks, forming red to yellow soils common in the southern United States and tropical climates. Topography, the height and shape of the land structure, influences the depth as well as the texture of soil. Soils are usually deeper on flat tops than the bottoms of hills. They start out shallower and need more protection from erosion on slopes and hillsides. In wet climates, low areas can become waterlogged, turning into peat bogs. In dry climates, low spots are apt to become pockets of salty soil. Animals and plants are a source of organic matter and many nutrients, released either by decay after they die or in animal wastes such as manure. Direct effects of living creatures range from burrowing of earthworms or moles to large-scale earth moving done by humans. Finally, time allows all the preceding factors to work together. Over eons, rock and sand break down into the smallest clay particles. Younger soils often have little clay. Reading the layers. As the different soil-forming factors interact over thousands of years, soil matures and forms distinct horizontal layers. The thickness and nature of the layers will vary in different soils. In certain soils, some layers are hard to see or aren't even there. You have to dig 2 or 3 feet deep to see the layer cake effect. If you run into bedrock when you dig, your soil is very shallow. It's hard to change the overall depth of soil, at least within a single lifetime. Within garden areas or raised beds, you'll need to bring in good quality topsoil, or you can make lots of compost to add to your existing soil to thicken it. If you were to dig a hole deep enough, you might encounter groundwater, the water table, before you reach underlying bedrock. If the water table is near the surface for much of the year, it can stop root growth as effectively as a layer of solid rock. What your subsoil says. Though digging a deep hole takes much effort in most soils, examining subsoil can tell you a lot. Different colors show how well the subsoil drains. which in turn affects the drainage of the overlying topsoil. If you see red or yellow subsoil, that indicates lots of iron oxides from weathering of plant parent materials, usually indicates good drainage, often indicating acidic soil, and is commonly found in warm climates. Blue or blue-gray subsoil indicates lack of oxygen, and therefore poor drainage, common in thick layers of clay. A white to ash-gray subsoil indicates nutrients and humus have been leached away. It usually sits above a darker layer where the leached nutrients and humus have been deposited. Often indicates acidic and or sandy soil. Is common under pines and similar trees. An even medium brown subsoil indicates adequate drainage. Pale subsoil, with little difference from the topsoil, is very young or poorly developed soil. The original topsoil may have eroded or been removed as by bulldozing during housing construction. Dark brown subsoil indicates abundant, usually decomposed, organic matter, usually occurring only in peat or muck soils where former wetlands have been drained. Patches or streaks of different colors in the soil indicates pockets of poor drainage in different sorts of soils. See specific colors for more information. Plant roots may have trouble moving from one pocket into the next. If the roots all end up at the same depth, this indicates a layer of compacted soil, hardpan, or, in dry climates, a cemented layer of caliche, usually causing poor drainage, and that hampers plant growth. Master gardening tips. To evaluating land, some soils are naturally well suited for gardening. They require the least effort to be turned into super soil. To see if you have such soil, check the list below. The more your soil differs, the more work it will be to get super soil. Adequate soil moisture. It needs to be enough water available from rain or irrigation to support a variety of plants. Adequate drainage. The water table stays below the depth at which the roots grow, and the area isn't flooded for more than once every 2 years. Adequate soil depth. That there's enough topsoil over the bedrock, hardpan, or gravel to allow for root growth and moisture storage. Lack of rocks. Gravel and stones and boulders aren't so plentiful that they interfere with tilling or plowing. Ease of water infiltration. The soil should be able to absorb at least 0.06 inch or 0.15 centimeters of rain or irrigation water per hour in the upper 19.7 inches or 50 centimeters. Balanced chemistry. The soil shouldn't be extremely acidic, alkaline, saline, or sodic. An even topography. Any slopes should be gentle so the soil doesn't erode easily and so that it's easy to move loaded garden carts or lawnmowers across it. Moderate temperature. Average annual soil temperature should be higher than 32 degrees Fahrenheit, 0 centigrade, and the average summer soil temperature should be higher than 46 degrees Fahrenheit, or 8 degrees centigrade. Sand, silt, or clay. One of the most important characteristics to know about your soil texture is simply the relative amounts of different sized mineral particles present. Soils contain a mix of different particle sizes and are described by particle size that dominates their particular mix. While some people call sandy, silty, or clayey their soil type, what they're really describing is its texture. Sidebar, did you know where the action is? The surface of soil particles is where much of the water and nutrient reserves are held. It's also where many important chemical reactions take place. Think of particle surfaces as tiny magnets. More surface area means a greater ability to hold water and nutrients where plants can get them. Fine clay can provide 10,000 times more surface area than the same weight of medium-sized sand grains. 1,000 times more surface area than silt. A pound of pure clay provides up to 90 acres of surface area. Texture has a major effect on physical properties of the soil. As particle sizes get larger, the spaces between the particles gets larger too. This explains why sandy soils drain more quickly than other soils. The smaller the particles, the more surface area they provide for holding water and nutrients. This is why soils containing more clay have a greater ability to hold nutrients and moisture. As you might guess, there's a trade-off in the advantages offered by different textures. Too much clay results in a soil with plenty of nutrients, but problems from poor aeration and soil drainage. Such soils are described as heavy. Too much silt can cause drainage problems. Too much sand means there's never a drainage problem, but you have to keep adding fertilizer, as most washes away. Such soils are described as light. The best soil texture isn't made up of all medium-sized particles, but of a balanced mix of sizes. Loam is a technical word used to describe this ideal texture. Such soils are the best ones for gardening and farming. Loams are usually divided into sandy loam, clay loam, silt loam, even silty clay loams. In our illustration, we see the finest soil particles, those smaller than 0.0001 inch and are too small to see, are the clay particles. The next largest are the silt particles, which are larger than clay, but smaller than 0.002 inch and still too small to see. Pure clay, or silt, feels mostly smooth between your fingers. Sand particles range from 0.002 to 0.08 inch. They are usually large enough to see and feel gritty between your fingers. Anything larger than sand is considered gravel.